Okay, this is more of section 2.6, modeling. And in this video, I will cover page 109, 110, numbers 8 and number 12. Be sure that you have your calculator ready to go. I will pause the video here to give you an opportunity to draw the picture, copied it straight from the book, and get your calculator ready. Okay, part A says express the area of the rectangle as a function of x. Okay, so area of the rectangle as a function of x. So area, length times width, base times height, whatever. Length times width, base times height. Okay, so in this particular rectangle, the base, I know that from the origin to this point right here, notice it's not 2. The origin to this random point right here is also known as x. Therefore, from the origin moving to the left is also x. It's some random point. Maybe this point is 1.7. Maybe it's 1.36942219. Whatever. It's some value x. So that's going to be a base of 2x. Oops, I almost put w there. 2x. The height is y. The height is y. Well, I don't know y. Oh, I sure do. Y is root 4 minus x squared. That is it. That is the area of this rectangle. All right. The perimeter is in the next part. So perimeter, add up all the sides. So the perimeter, we have x, 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 x for a total of 4x. So I got that because there are, the base has, or the length, however you want to look at it, is 2x. And then at the top you have 2x as well. And then the height is 4 minus x squared, but we have that twice. I wrote 4, that should say 2. And I'm not using erasable pen. That should be a 2. There is your perimeter. Part C and D ask you to plug it into your calculator. So I will pause the video, plug in both the area and the perimeter at once, and then we will answer the remaining questions. Okay, so I have here y equals, I plugged them both in. I'm going to start with the area. And when you do a zoom, I always do a zoom 6 just to kind of see what it looks like. And it's really funky, but that is what it looks like. Talking about area, lengths of sides, it can't be negative. So I'm going to change my window to go from 0 to 10 and 0 to 10. Makes no sense to have any negatives in these problems. It asks you to find the what value of x maximizes the area. Second trace, 4 for maximum. Now, it took me a while. I had my cursor going to the left. It took a while to show up. Enter. And set your right bound. Enter. Guess, and there's the answer, 1.41. Do the same thing, go back to your y equals. I'm going to turn the area equation off by pushing enter. And I'm going to turn the perimeter equation on by pushing enter. So graph. Really funky. I used the same window. I used 0 to 10. And 0 to 10 for x and y. It doesn't make any sense to have any negative values in this problem. And they ask you to find the maximum. So second trace number 4. And just using my left arrow key, it's all I'm doing is I'm pushing the left arrow key. There it is. I pushed the left arrow key until that cursor came up. Enter. There's my left bound. Enter for my right bound. Guess is just put the cursor on top of the point that you're looking for, push enter, and it is approximately 1.8. When X is 1.8, the maximum area is 8.9. Okay, there's number 8. All right, let's look at number 12. 12 is pretty funky. I'm gonna warn you that we're gonna get some really weird fractions, square root things. The answers are very strange, but just because they're strange doesn't mean you didn't do it right. So number 12 says we have a wire that's 10 meters long, and we're going to cut it into 2 pieces. It's 10 meters long, and we're going to cut it into 2 pieces. One piece will be shaped as an equilateral triangle. The other piece will be shaped as a circle. Okay, cool. Triangle and circle. Express the total area enclosed by the pieces of wire as the function of the length x of a side of the equilateral triangle. Okay. I'm going to have an equilateral triangle, and I'm going to have a circle. Beautiful circle. They're telling you that x is going to be the side of the triangle, which means that this is an x and this is an x. Okay, so to make the equilateral triangle, I've used up 3x. To make the equilateral triangle, I've used up 3x. What's left, therefore, is 10 minus 3x for the circle. Okay, gotta find the area of this triangle. 30, 60, 90. This is now 1/2 x. Equilateral triangle, I dropped the perpendicular. So this is now 60, and this is 30. So if you remember your relationship in 30, 60, 90 degree triangles, opposite the 30 is x, opposite the 60 is x root 3, and opposite the 90 is 2x. That's from geometry. So opposite the 30 degrees in this case is 1/2 x. Opposite the 30 is now 1/2 x, which means that opposite the 60 is root 3 over 2x. That's my height. Okay, so the area of this triangle is 1/2 the base, which is x, times the height, which is root 3 over 2x. The area of this triangle is root 3 over 4 x squared. All right, the circle. So the length of the circle is 10 minus 3x. So that is the circumference. I'm taking this piece of wire, it's made into a circle. That is the circumference. Therefore, see, circumference is 2 pi r. And to find area of a circle, I need the radius. So I'm going to divide both sides by 2 pi. There's the radius. Okay, area of a circle is pi r squared. Well, I know r. I'm going to square it. So this is going to be 10 minus 3x over 2 pi. That's my r squared. And then the pi in front. Pi r, this mess, squared. Here we go. So this becomes pi. 10 minus 3x quantity squared is 100 minus 60x plus 9x squared all over 4 pi squared. Reduce pi and the pi. So the area of the triangle plus the area of the circle, which is 100 minus 60x plus 9x squared over 4 pi. That, my friends, is big kid math. Check that out. And that is the right answer. That is indeed the right answer. That ends today's lesson.